Most developer workflows use Claude Code at a fraction of its capacity. Treating an orchestration engine like a text box yields predictably unremarkable results. There is a massive gap between surface-level prompting and the automated engineering occurring below the waterline. At the very tip, most developers settle for the most basic form of interaction. Level 1 is the prompt engineer. In this mode, communication is strictly one way. You type a command, wait for the AI to generate a response, and then manually paste that code into your file. This creates AI slop. You get generic variable names like data or result, and code that follows the most conventional, unoptimized patterns possible. It functions, but it lacks any awareness of your specific project architecture. This level is habit-forming because it feels productive. Generating a boilerplate API endpoint in seconds is faster than hand coding, but it ignores the long-term cost of the generic code you are importing. Treating a high-performance terminal tool like a typewriter guarantees a future of manual refactoring. The time saved during generation is eventually lost to cleaning up the inconsistencies. Moving to level 2 requires shifting from dictation to architectural dialogue. This is the role of plan mode. Before writing a single line of code, the AI proposes a structural approach and asks for clarification on your requirements. This collaborative process identifies design flaws early. It forces you to decide if a notification system should be ephemeral or persistent, and which delivery channels are mandatory before the logic is hard-coded. However, this level introduces a risk of passivity. If the AI asks intelligent questions, it's easy to stop providing your own technical constraints and rely entirely on the model's suggestions. A plan can be technically sound, but still lead to a production failure if the developer doesn't volunteer critical context, like a zero downtime deployment requirement or specific legacy database limitations. Even with a collaborative AI, the human engineer must remain the primary source of structural thinking. Without that input, the collaboration remains shallow. Deeper levels of mastery move away from the interface and into the raw technical management of the terminal. Level 3 is context rot. Past 50% capacity, attention degrades. It mixes conventions, ignores instructions, and proposes dead paths. Maintain performance by using /compact to purge history. Rather than the entire repository, surgically provide only the specific interfaces and logic blocks needed. You can automate this alignment by using a claude.md file in the project root. This ensures every session begins with your specific architectural rules already in memory, saving tokens on repetitive instructions. At this stage, productivity is defined by how effectively you protect the model's limited attention span. Level 4 transforms the terminal into an extensible hub, enabling direct interaction with external system environments. Through Model Context Protocol, or MCP servers, the AI gains the ability to query your Postgres databases or interact with your file system without human intervention. Instead of copying error logs into a prompt, you can instruct the AI to analyze slow queries directly. It can examine the execution plans in the database and generate the specific SQL needed to optimize them. The danger here is tool overload. Giving the AI access to too many integrations causes it to spend excessive tokens evaluating which tool to use, which slows down the response time. Mastery requires stripping the configuration down to a handful of essential daily servers. Adding a tool is only beneficial if it removes a recurring manual bottleneck. Otherwise, the integration becomes a source of unnecessary complexity for the AI. Level 5 focuses on automating the prompts themselves. A skill is a structured instruction set triggering a complex sequence from a single input. One command can force checks for security, performance, and style in a repeatable order. However, overlapping instructions can lead to chaotic skill sprawl and inconsistent results. To maintain the system, you must routinely merge overlapping skills and archive any automation that hasn't been triggered in several weeks. By this level, Claude is no longer a generic assistant. It is a customized engineering system built specifically on your logic. At level 6, you reach the most complex tier of interaction, the orchestrator. This involves running multiple instances of Claude Code simultaneously. Instead of one AI handling one task, you coordinate a group of parallel agents working on different parts of the codebase. The infrastructure is Git worktrees. By checking out the repository into separate directories, you allow one agent to build the backend API, while another builds the UI, and a third writes tests. Your role shifts from writing code to managing information flow. You provide technical briefs and review architectural decisions from 3 parallel streams. But the financial cost is significant. Running multiple parallel agents duplicates context initialization, rapidly consuming your API credits. Parallel orchestration trades raw token cost for time. It is the most aggressive way to compress a development timeline, but it requires precise coordination to prevent the logic from diverging. The most significant friction point of Level 6 is the coordination debt incurred when merging these parallel workstreams. Isolated agents inevitably make different architectural assumptions. The API agent might change a response structure that the UI agent was relying on, requiring the developer to spend hours manually resolving the integration conflicts. Because of this overhead, multi-agent orchestration is only efficient for large features. For a dashboard build that would normally take 12 hours, parallel agents can reduce the work to 5 hours, but for small tasks, the merge time ruins the return on investment. Navigating the full depth of the iceberg requires shifting from a coder who writes lines to an architect who manages systems. When the infrastructure is properly managed, the result is a massive increase in output per engineer. This has been the Raw Deep Tech. Thanks for watching, and I will see you in the next one.